What's up? This is hashtag Behind Efficient Buildings. I am Zaina together with my colleagues Jamaica Marza and Eliza May talking to you for today's episode about HVAC system for hospitality buildings. And before we begin our podcast, we would like to extend our gratitude to the very generous sponsor, Mr. Henry Sai Charot, Mr. Henry Chongayo. We at Code 8212 want to send our warm thanks and appreciation and hope you know how much you are valued. And with that, we move on to the topic of our podcast about HVAC system for hospitality buildings. But before we proceed to our main point, let us all know first what is a hospitality building. A hospitality building is a facility that provides comfort by employing the marketing of recreation, food and beverages, lodging, tourism, and travel. A hospitality building is found in hotels, resorts, casinos, and alike. Customer experience is the principal profit, hence, flexibility in providing hospitality services is necessary. Specialized techniques are used in this industry to deliver solutions and sales. Approaches such as HVAC systems, in most cases, make the hospitality business manageable and conventional. As stated, in most cases with hotels, the satisfaction and well-being of the guests are critical to the prosperity of the business. Thus, HVAC systems are known and proven to be the necessary to improve and maintain overall air condition in hotels, especially when providing optimum style and comfort to guests. And now, let us proceed to knowing the definition of HVAC. HVAC stands for heating, ventilation, and air conditioning. This is a system that provides comfortable temperature, air circulation, and humidity around a building. The proper ventilation maintains the indoor climate and supports the appropriate airflow of heating and air conditioning components. In the hospitality industry, HVAC system is valuable because it influences a customer's experience. As reported by hoteliers, about 40 to 80% of the total energy consumption of a hotel is consumed by the hotel guest rooms. Moreover, if managed properly, an energy-efficient HVAC system reduces energy charge by 20% and decreases carbon footprint. A centralized HVAC system enables a user to control the temperature's variability inside a particular space without compromising mobility. It also allows an advantage of cleaner air and reduced airborne stiffness. This system exists to move warm air into and out of a room. As an illustration, a hotel's air conditioner captures the warm air, then a blower facilitates movement and turns warm air into cold air. In a nutshell, an HVAC system cools or heats a space by feeding air through ducts. The design for an HVAC system is important as it controls all factors of heating and cooling components. So first is efficiency. Improvement of HVAC system's efficiency generates decreased expenses and cost. Second one is ventilation. The absence of proper ventilation causes poor airflow and indoor air quality, respiratory issues, high humidity, moisture, and mold. Third one, code compliance. The building codes and standards regarding the HVAC system are applicable for its design and operation. These rules and regulations shall be followed to produce a functional and safe design. Next, equipment sizing. If a piece of equipment sizing is oversized for a space, it will rapidly heat up. If it is undersized, it will likely work over time, but both scenarios lead to equipment malfunction, but can be prevented with proper load calculations deliberated by experts. And lastly, the ductwork installation. The ductwork supports the comfort of the HVAC system. The suitability of duct sizing and installation avert the loss of temperature as conditioned air moves along the ducts. Additionally, angles, distances, and paths affect airflow, thus projecting unimpeded air travel within the ductwork. Moving on, let us now talk about HVAC system types and its components. First, we have VTAC, Vertical Terminal Air Conditioning System. This vertical HVAC system is a compact design installed in concealed spaces like closets. It can manage the temperature of multiple rooms at once. Additionally, it is economical and flexible as it has a direct utilization of ventilation air. VTAC works by drawing out the air inside the room through the return. The processed cool air is then returned to the room through the supply. The outside air is taken in and used to assist in the condensing and cooling process. The excess warm air is sent back to the atmosphere through the exhaust. Next up is PTAC, Package Terminal Air Conditioning System. This system is installed underneath or against a wall. In most hotels, PTAC is utilized as a self-contained air conditioner for rooms. It does not use outdoor air to cool or heat a room but operates a packaged terminal air conditioner component and recycles the indoor air within the room. The compressor of the PTAC unit injects refrigerant into the coils, and the air turns cold as it passes across the coils. Simultaneously, the coils remove the humidity and heat from the air, then propelled outside through a grill. To warm a room, a heat pump can be applied and drive back the PTAC cooling system. Succeeding to PTAC is VRF, or known as Variable Refrigerant Flow. This system contains an outdoor central condenser on the roof. Each hotel room has fan coils attached to the outdoor unit. The VRF condensing unit will inject cold refrigerant into each fan coil and cools the room. When warming up the room, the condensing unit infuses hot refrigerant into the fan coils, and as air goes across the coils, warm air is blown off the ducts. The VRF system is conveniently used in both cooling and heating systems. And finally, HVRF, Hybrid Variable Refrigerant Flow System. This system includes an HBC or Hybrid Branch Controller. This is affixed to the outdoor heat recovery unit by the use of traditional refrigerant ducting. Additionally, this involves an energy-rich refrigerant at the HBC performs as the heat exchanger. In line with this, an evaporator also facilitates by collecting the energy as the water flows and delivers it to the fan coils. The HVRF is different to the traditional VRF since the HVRF system uses water instead of refrigerant in the space. The outdoor components produce a mixture of liquid and hot gases in the HBC. Afterwards, the mixture goes to the heat exchanger to heat the water and then cools the liquid and delivers a cooling system to the hotel rooms. And to sum up everything we've tackled, a hospitality building requires simultaneous cooling and heating in spaces. The installed HVAC system shall be able to deliver an effective service to fulfill the customer's experience and the building's nature. Therefore, the best solution for a hospitality building is a HVRF or Hybrid Variable Refrigerant Flow System. This structure is water-based and runs through a modular system. Then the piping and the ducting method is also more convenient because it can now be installed in a continuous system. And with that, we are now ending the podcast. Thank you so much for joining us again. This is Zaina together with Jamaica Marza and Eliza May. We'll see you guys next time. Bye!